On October 15th through the 17th, Noodle had the opportunity to gather in San Diego with approximately 100 supply chain leaders. The Zero100 live event kicked off our partnership with this community of individuals who are looking to usher in the next breakthrough in supply chain, 0% carbon and 100% digital. With Noodle's own mission of creating a world without waste by utilizing artificial intelligence, we couldn't think of a better group of people to spend our time with. Kevin O'Mara's keynote presentation set the stage for the 2024 megatrends that chief supply chain officers and supply chain executives are most focused on, and the topics that we were going to be diving into at the event. To no one's surprise, artificial intelligence was at the top of the list, defined as the must-win productivity challenge for 2024 and beyond. Specifically, utilizing artificial intelligence for supply chain planning is drawing increasing interest in the calendar year 2023. We are convinced that this increase in interest is due to supply chain leaders recognizing that the advanced planning systems that they're utilizing to make everyday decisions were built in the 1990s, and that happened prior to the explosion in capacity of computers and the dramatic reduction in compute memory and storage costs. It was these fundamental changes that have led to tremendous artificial intelligence breakthroughs, most notably found in ChatGPT. And supply chain leaders across industries are desperate for the same kind of breakthrough in their supply chain planning processes. We believe that Noodle.ai is uniquely suited to help companies move beyond the current deterministic planning systems that were built 3 decades ago by utilizing artificial intelligence to first harness the power of probabilities and ultimately transitioning to supply chain planning powered entirely by generative AI, graph neural nets, and reinforcement learning. In the following presentation, you're going to hear from Steve Pratt, our CEO, who will focus on how we've built the data science and software engineering and ultimately the intellectual property to make this evolution possible. Then Trevor Miles, the longtime industry thought leader, will explain how the breakthroughs that Noodle has ushered in are applied to practical applications in supply chain planning. One of the key things that we hope you take away from this presentation is that it's possible right now to unleash productivity gains in supply chain planning with Noodle. As Kevin O'Mara said in his presentation, you don't have to wait. AI is for everyone. Don't hesitate to contact us so that we can help you leverage the power of probabilities available to you right now and ultimately apply artificial intelligence in practical ways to your supply chain planning decision making.
Monday, May 14th, 2018 was a super memorable day. On that day, a team from Noodle.ai met with a leading consumer brand company. The meeting, other than being super memorable, was shocking and changed the direction of our company. They wanted to see if Noodle.ai and our data science could help with their supply chain planning. They described that they had over 100,000 SKU DC combinations. They needed to ship products to over 50 countries. They had implemented and upgraded the most advanced ERP system. They had implemented and upgraded the most sophisticated advanced planning system. They were using advanced integrated business planning processes. They had a great team and they invested in training. But still, they described how a typical week went. So over the weekend, their advanced planning system would run. And on Monday morning, they would show up in the office and they had somewhere between 500,000 and 750,000 inventory imbalances that they needed to wrestle with. They would spend Monday, Tuesday, Wednesday trying to figure out what was real, what were false alarms, and what really mattered. On Thursday, they would all have all kinds of meetings. They would have phone calls, texts, and do the best they could as they downloaded the remaining decisions onto spreadsheets and struggled with what the right decisions were. Fridays were very frantic, and they would just reply to urgent pleas for inventory. They would expedite way too many things. And at the end of the week, they would go home not feeling great about what they had done. And wait for the inevitable criticism from senior management. As the result of all this, their fill rates were too low, their inventory holding costs were too high, and their transport systems were unacceptable. So, based on some courageous leadership from our customer, they implemented the Noodle demand and distribution software into their planning system. And Mondays were still tough after the implementation. They would show up and there would still be thousands of decisions to be made, but the decisions were ranked by the importance to the company, the risk that they were posing to the system, the probabilities that they would have upside risk or upside opportunities with additional revenue, or downside risks with additional cost. And then they would basically spend the week making informed strategic decisions about what the intention was and where they wanted to take the risks. And they felt really good about what they were doing. The morale increased. They got increased praise from the executives, and they had increased the profitability through the Noodle system by several $100 million and increased the productivity of their planners by over 50%. But I'm getting way ahead of myself. So this is the first Zero100 that Noodle's ever been to. And I really want to thank people for the invitation here. It feels like you really are kindred spirits, that the intention of Noodle.ai is to use data science to create a world without waste. And I must say, I'm somewhat jealous that the Zero100 team has basically said the same thing in 4 words, and it took us 8 words to say it. So we're really glad to be here and appreciate the opportunity. Since it's our first time here, I thought Trevor and I would start with kind of an introduction to Noodle.ai, sort of where we came from, the origin of the company, where we are today, and where we're going. So I guess the original thought for the company goes all the way back to early in my career when I was studying satellite communications and a lot of calculus and probability theory. And the objective of designing a great satellite communication system is to be able to find signals and noise and to be able to hide signals and noise. And my first job, which was doing classified work for the US government, actually focused on space electronic warfare, which really doubled down on being able to protect our systems so that we could get information through to other satellites in very, very high noise environments. And I was also struck that the formula for information is actually a probabilistic equation. And I thought that was really cool. Sort of fast forward a little bit and had my first experience with AI in the early 90s, working with the US Coast Guard. And what we did is to collect all kinds of data that we thought might provide some signal to indicate which ships were drug smugglers and which ships were not drug smugglers. We trained an algorithm that learned patterns from those data and then would identify which ship was likely to be a drug smuggler. The problem is that the computers were so slow that typically the system would crash. And even when it did run, that by the time it got out on input, that the drug smugglers were long gone. But I thought it was really amazing that instead of being explicitly programmed, that an algorithm could learn from data and learn patterns and constantly improved. And I thought that someday this is going to have a big difference, make a big difference in a lot of the way that we make decisions And so we're sort of got stored away in the back of my brain. So then a couple decades in the trenches of implementing technology and learning that, yes, it's important to have great technology, but it's also important to have all the surrounding capabilities, because at the end of the day, what really matters is, did you create value? Did you move the needle? So it's really important to pay attention to the technology stack, the data pipelines, processes, people, incentives, job descriptions, metrics, change programs, everything around it to make sure that that it worked. Then in 2014, after I'd started a company and grown it to be big, and then decided to leave, I basically decided to take the year off and did a lot of research, a lot of reading, studying, and came to the conclusion that those barriers that existed back in the 90s had been crossed, that data was now affordable enough, the computing power had gone up more than 1 million-fold, and the algorithmic sophistication was there, so that AI was a real possibility to make a difference in the enterprise. So having just sort of done a 10-year sprint in building a company, I really didn't want to start a company. So I teamed with a private equity company and said, hey, let's go buy a company that is focused on applying artificial intelligence, machine learning in the enterprise, and doing that to create good. And so I went with the private equity company and basically scoured the world looking for this company, and came to the conclusion that it didn't exist. So went to a brief stint running all the Watson implementations worldwide for IBM Global Services, and didn't think that was the right fit, because it was focusing only on text data rather than numeric data. And I thought most business problems were predominantly numbers-based rather than text-based. So I went back to the private equity company and said, you know, that company that we were thinking about, I think it really needs to exist. So if you'll help me fund it, I will go start it. And so enter Noodle.ai in 2016. So the original idea was to basically do custom development of software to apply to different parts of a company to create value. In fact, this is a snapshot of what I call the Enterprise AI Navigator that I developed. Came up with hundreds of different ways that AI could help in a company, identified the key metrics, the data, the likely algorithms that would be that I thought would be most successful, and said, like, this is going to be easy. There's going to be hundreds of things that we can do. So we came up with the initial game plan. We hired ridiculously talented data scientists from the top universities, the top companies, and set out to work with companies to find important problems and solve them using AI and machine learning. And the basic flow of what we were going to do is get the data, prepare the data, find the algorithm, train the algorithm, build the UI, and then deploy to production. Seems like a great idea. Well, actually, it turns out it wasn't a good idea. And here's why. So what we learned is that when you're training an AI algorithm, you get training data, and those training data are not perfect. And we could deal with that. But when you put it into production, you find out there's a lot more bad things happen, and that production data are typically worse than the training data, and that we really needed to have a technology solution to this, and couldn't just deploy something into production. We also found out that AI is not the answer to everything, and that the human brain is actually amazing, and that we needed to use the power of the human brain teamed with AI to really make a difference. We also learned that it was really important to give the users of the system a sense of probabilities and risk and how certain numbers were. We had the observation that most enterprise systems only output one number and don't give the user a sense of the likely upside or downside of that number. We also learned that the software engineering around the AI is just as hard and possibly harder than the AI itself, and that we needed to develop pioneering software engineering techniques that could run a learning, evolving, algorithm right in the middle of it in production without going down. We also reconfirmed that technology is not sufficient and that you need to do all the other things. And what really matters is if it creates value. We also learned that a lot of enterprise AI projects fail, because they follow the scientific method of a hypothesis test, and not all AI projects lead to a useful and actionable output, and that we needed to go from custom projects to focusing on specific use cases and go really, really deep and develop products that we had deployed multiple times and could learn what worked. We also learned the good news, and what gave us a lot of confidence is that when done properly, that AI products can produce jaw-dropping results if done properly. So this led to a lot of pioneering development in technology. These are some of the patents that we developed during that time. We have patents for the underlying platform for artificial intelligence, using a next one on using interconnected machine learning models, then a bunch of them around data, around the cause and effect of data anomalies, how to detect outliers, spurious outliers, how to monitor the health of a system, and then how to look at signatures for the different warning recommendations. All of these things are really centered around not only the AI, but all of the software engineering to make sure that you can have a reliable, scalable, and powerful enterprise AI technology running in production. Then in 2018, at the beginning, I talked about that meeting and the subsequent meetings and customers in that year, is that we had the epiphany that supply chain was really where we wanted to focus. Basically, we said it's data rich. I know that a lot of you in supply chain are saying that your data is not very good. As the saying goes, well, you should see the other guy. So I think across the enterprise that supply chain has some of the best data, mostly because most companies have implemented and spent hundreds of millions, in some cases over $1 billion, implementing advanced ERP systems and advanced planning systems. And the data in those systems is the best in the company, possibly with the exception of finance. And so they gave us a lot of encouragement in this. We also learned that there's a lot of really valuable and undiscovered patterns in supply chains, and that the current technologies that were being used simply could not discover these patterns. We also saw that the probabilistic thinking can really help supply chain operators, that their systems were giving them a single number outputs, either for demand or for supply or for inventory imbalances, and really did not give them a sense of risk. And we thought this could make a really big difference. We also saw that supply chains are a critical function, and importantly, there was a huge amount of waste in supply chains, and that was great because it was consistent with our intention of creating a world without waste. We also saw, as we talked to a lot of different companies, that current systems are frustrated, that they're trapped in long, expensive upgrade cycles that had a lot of promises but didn't add much value, and that really there were no dramatic breakthroughs that were happening. And we thought that the application of these new technologies and these new approaches could provide that breakthrough. And our conclusion that is almost a perfect problem for the right AI products. And so we really got to work and dedicated the entire company to this pursuit. So what we found from early customers and working with hundreds of brands across the world is that we could dramatically outperform the advanced planning systems in both demand forecasts, supply forecasts, and the inventory allocation recommendations, and that we had dramatic increases in the efficiency and profitability of the teams we worked with. We also learned that there's a lot of edge cases, meaning that there was a lot of exceptions and a lot of things that change in supply chain, and that we really needed to develop a fault-tolerant data pipelines that could handle this and still run in production. This is a very difficult thing to do, and took us 3 years to solve it. We also saw that in some cases, and certainly not a majority of the cases, but in some cases, that traditional techniques were actually better than the AI, and that humans were better than the AI. So we made sure to include those in the system and build in those capabilities into the system, and really have a meritocracy on who was the best at each role, and to optimize that. And we found that it's again that it's very important to have the necessary surrounding technologies to support the AI algorithms. And so we had to build that, and that took us 4 years to solve. So this is kind of the journey of us in supply chain. As a result, we have developed some, again, pioneering technology in supply chain AI. For example, our probabilistic forecasting techniques that we're super excited about, and getting great feedback from customers who have been in production for more than 4 years. We have patents in controlling inventory and supply chains, predicting supply chain performance, and controlling production resources in a supply chain. And then this last one is one that we're super excited about. This is not on our products right now, but the AI is complete. It's been tested on customer data, and we think is really revolutionary, and that is applying generative AI to optimize supply chains. And Trevor will talk a little bit more about this. So on generative AI, I just wanted to have a quick detour here and talk about what we mean and what is generative AI. So it's important to understand that there are 3 distinct categories of generative AI. There are large language models, which are basically getting 99+% of the attention in generative AI. It's important to keep in mind that large language models only understand text and documents. And of course, the most known of these is ChatGPT. But there are 2 other categories of generative AI. The first is large image models, which generate new images from inputting image data and video data. Examples of this would be like Midjourney, and also interestingly, the Hollywood strike was largely about the use of AI to generate images of actors. In fact, if you looked at the latest Raiders of the Lost Ark, you'll see that Harrison Ford was de-aged in the movie, and there's a lot of concern that in the future that Hollywood studios could simply generate images of an actor rather than paying the actor to do the work. So this is a really powerful technique of generative AI also. The third one is where we're really excited and we think is the future of supply chain, and that's large graph models. So what a large graph model does is it models data in nodes and connections. And of course, supply chains are naturally made up of nodes and connections. There are manufacturing nodes and there are distribution nodes, and there are connections, which would be different transport lanes. So this is being used, interestingly, by AlphaFold, which is a Google subsidiary, to develop new drugs. So what they're doing is using, they are modeling a protein molecule as a graph, and it's sort of naturally a graph, and saying, generate a new set of proteins that are folded together that have the potential of curing a specific disease. And this is really cool, and I think something to look for in the future of healthcare. What we're doing in Noodle.ai is to model a supply chain as a graph, and again, it's a natural graph, and then saying, based on a prompt, which would be a demand signal and a supply signal, and all the other data inputs and external data, that generate a supply chain plan that will optimize certain KPIs and certain risk preferences. So it's important to understand that, again, the three categories of generative AI are LLMs, LIMs, and LGMs. So I'll finish up by just talking about one more customer example, and this is a Fortune 250 CPG company. And we went live with them in mid 2020, and that based on our distribution recommendations, that they were able to achieve an uplift from their advanced planning system of about $100,000, again, of profit improvement in fill rate per week. Then what happened is there was an issue in the plant, and it was sort of all hands on deck. And actually, a large part of the planning team had to go actually work in the factory, and so the manual approvals where the planners would sit there and say, yes, I accept the AI recommendation, or I want to modify the AI recommendation, or I want to reject the AI recommendation. That simply there weren't people there to hit those buttons, and so the value that it was providing was dropped significantly. Then, based on their internal analysis, what they saw is that actually, when the planners were rejecting the AI recommendation, they were actually destroying value. So they made the decision, and we implemented basically auto approval of the recommendation. So when an AI would make a recommendation, it would automatically change the plan, and then the planner could then change it, but the default was that it was auto accepted. And so the value generated from the system more than doubled during that time period. Then something really interesting happened, is that a new executive came in and basically said, hey, what is this system from this company with a funny name? Hey, I want to do an experiment. I want to turn off one of the major brands. So they basically turned off Noodle for $1 billion brand, and almost immediately the fill rates dropped, and very impactfully, the transportation costs, the redeployment costs, went through the roof. So they told us after the trial to please turn it back on as soon as you can. So we did. A lot of the latent values spiked. In fact, it went over $1 million of added profitability in 1 week. And so we've been operating at high weekly profit ever since then. So great story for us, and kind of an interesting experiment of turning it off and then turning it back on. So thanks very much. I'm going to turn it over to Trevor, who is really going to talk to you about sort of where we are and where we're going in our products. So appreciate your time, and thanks very much.
Thank you for that introduction, Steve. My name is Trevor Miles. I'm thought leader at Noodle, joined there recently, and I'm here to explain what Steve has talked about and its relevance to supply chain planning. And why do I feel like I can explain that? Well, I joined i2 Technologies in 1994. I was employee number 20 in Europe, 200 worldwide, stayed with i2 through the glory and boom and bust for 12 years. And I then joined Kinaxis for around 12 years. I developed the ideas of concurrent planning while at Kinaxis. Of course, I gave word to its capabilities. The capabilities were always there, but concurrent planning, and also the tagline of no sooner act faster. I was also chief strategist at SAP Digital Supply Chain for about 18 months. And since then, I've done some advice to startups, and I was very pleased when Tim Krug called me and asked me if I would join him at Noodle. It's very exciting. I've always liked the idea, or actually supported the idea of probabilistic planning, because that is my history. Even before joining i2, I worked for Cooper's Livebrand using stochastic systems to actually plan or design a supply chain. And it was very strange to me when I got to i2 Technologies and there was only one number for everything. Demand, supply, lead time, everything else like that was simply one number. So anyway, let's dive in. And the question is, why change? What problem can existing planning systems not solve? And I gave you a hint. It is all around the probability that exists and the uncertainty that arises from that in your supply chain. But to try and explain this in layman's terms, because it's a different idiom, and I think it is something that we can actually more easily understand outside of supply chain, I'm going to use the fact that my daughter, who lives in London, has been interviewing for jobs recently, and one of her jobs required her to go to Heathrow. And to do that from Peckham, where she lives, it meant that she had to take three trains with 2 changeovers. Of course, preparing for this, she went into Google Maps, and Google Maps told her it would take 1 hour, 13 minutes. So the key question is, when should she leave? And this gets into the heart of the matter. We all know that Google has given her one number. We also know that that number is not exactly right. So how much should she buffer in order to get to her meeting, interview on time? Well, Google doesn't provide her any information that allows her to understand how much to buffer. Because if that the time it took was between 1 hour and 10 minutes and 1 hour and 20 minutes, then she probably should leave 1 hour and 20 minutes before. But Google doesn't tell her that number at all. It doesn't tell her the variability. So she has no way of understanding how to buffer it. And of course, the other side of it is her risk profile. In this case, she's going for an interview. So her risk of being late for an interview is, of course, pretty damning. So her profile is very high. So when should she leave? Well, I'm guessing she's going to leave in at least 1 hour and 30 minutes, if not 1 hour and 45 minutes before, just depending on how sure she is of what the prediction given to her by Google and how much of a risk she anticipates of arriving late. On the other hand, if she was going for lunch with her friends, then she might in fact leave 1 hour and 13 before, and she might arrive a bit later. She might arrive 1 hour and a half later. and they can all sit around and moan while they having a beer and eating their food about the unreliability of the London Underground. But the consequence of her being late is much less, and therefore she can trust on the hour and 13 minutes. So if I wrap that all together, the key learnings is in all supply chains, even that one of going for an interview, there is an inherent uncertainty because of variability. We all know that variability. We talk about the demand plan not always being right. Well, the supply plan is not always right either. And uncertainty is buffered in many ways, but the buffer sizing depends on your risk profile. And the buffer size is also guesswork because there's nothing that existing planning systems give you that would enable you to make a decision on how big that buffer should be, because they cannot quantify that risk that's associated to the uncertainty, and they're based upon the variability. So what problem do we address? Let's start with the fact that making stuff in your supply chain means that you're making bets, thousands of bets, such as what will customers order and when? Where should I keep inventory and how much should I keep? What should I make and when? We can see that all of these decisions where we understand that inherently there is some uncertainty, but the key point is existing planning systems don't raise that uncertainty to us. As a consequence, we're making bad bets all too often. We don't mean to, we try our best, but without sufficient information, it is very difficult to make the right decision based upon the variability and therefore the action you should take based upon the uncertainty. So we place all of these buffers in there, such as freight and mode buffer, capacity and WIP buffer, sourcing and raw material buffers, because we absolutely do not know where that is, where we're actually going to see the demand, how much we're going to see. And as a consequence of making those bad bets, we create a lot of waste, stockouts and lost profit, transportation costs and CO2 emissions, labor costs and a whole bunch of nitrous oxide, etc., emissions in production. So we see all of the waste that appears. And of course, the most obvious one is that we all measure is the lost profit and lost sales in the demand side, but they migrate all the way through our supply chain. And the reason that we have to make those bets is existing planning systems cannot help you place good bets. As we've discussed, that is because existing planning systems provide one number plans. There's no indication of variability. And without that estimate of the risk and opportunity, we cannot evaluate the uncertainty and therefore the likely outcomes, because all of those planning systems are based upon deterministic algorithms. They're not based upon probabilistic or stochastic algorithms. And as we can see, it's like being that skier in a new location. You have no idea which is the best route. You have no idea where the hollows are. You have no idea what the state of the ice is, but you've still got to make a decision on how to get from where you are down to the bottom. So we've mentioned probabilistic planning a few times, and what is the difference between deterministic planning and probabilistic planning? The key is that probabilistic planning uses history and driver data to predict probabilistically what the outcomes are most likely going to be. So just again, deterministic systems, you've got one number for demand in quantity, and of course there's also the question of when is that demand going to appear. There's the ship date of when you're going to be able to send it to the customer. There's lead time of how long it's going to take you to get to the customer. And then there's the ship quantity of how much is going to be available to ship to the customer. And they all provide you single numbers for those values with absolute certainty. And of course, we know that none of those are correct. The result is unanticipated inventory imbalances, which means you can't deliver to the right customer at the right time and the right quantity. So the fixed rules of deterministic algorithms in these existing planning systems lead to infeasible plans, which drive a number of significant Fixed rules and deterministic algorithms lead to infeasible plans which drive a significant number of incorrect alerts. So what the consequences of that is, you have expedites that you should not have done. You anticipate that you can satisfy customer demand when you cannot. So there are lots of direct consequences of that. What does probabilistic planning do? Well, each of those numbers is represented by a distribution. With the maximum likelihood, you can see for ship date, lead time, and ship quantity, those are all roughly the maximum likelihoods are when you anticipate or where you have your deterministic planning solution, but demand is different. Demand, you're anticipating a quantity of 80 with the highest probability, which is different from what you had planned in your deterministic system. That all leads to the predicted inventory variability. We can see that there's roughly 21% chance of having exactly the right amount of inventory, but a 25% likelihood that you're going to be 5 units short, and around about 8% likelihood that you're going to be 20 units short, and about a 12% or 15% probability that you're going to be 10 units short. So now the question would be, what do you do with that? But the key point is that Noodle incorporates the impact of variability in all of the calculations and the results. This gives you a more accurate prediction of what is most likely going to happen. And therefore, you can define the corrective actions that reduce risk and waste. In fact, we do that for you. But let's discuss that all based upon this predicted inventory variability. But it's not only that, we also predict the most likely demand. And again, most likely is both quantity and timing. And same thing with supply is quantity and timing. When are you going to have appropriate supply to satisfy that demand? And we take that information, and first thing we do is we form those distributions around inventory variability. But of course, all planning systems or all organizations, more correctly, have to actually take an action. And the question is, how do we translate that distribution into a set of actions? This is where we use the concept of value at risk, which is a standard concept in financial planning, where they look at all of your portfolio and how much you should be in bonds, how much you should be in stocks, and how much you should simply be keeping in cash. And they work out based upon your risk profile, how much you should be investing in each of these areas, and also which stocks you should be buying, et cetera, et cetera. We use the same concept to take that probability distribution and translate that into actions that you need to take. The first thing is that the top line impacts, and obviously this is revenue, is the key thing. Bottom line impacts are excess and obsolete, inventory holding costs, expedites, all of these things that add to the cost side. And we're trying to balance then those top line impacts and bottom line impacts. Of course, we come to you with a standard set of value at risk calculations, but those are modifiable to suit your particular needs. And of course, the value at risk calculation can be modified to address the fact that some customers are more important than others, some regions are more important than others, some part of your product portfolio is more important than others, so that you get a balanced value at risk calculation. We then take that value at risk and translate into corrective actions by de-expedites, expedites, reallocation to different customers, all of these actions that you can take, and which actions then reduce the value at risk and therefore improve the likelihood of you being able to satisfy your business objectives. And therefore, we look at the highest probability of reducing your risk. That in turn, we can look at all of the actions that we have taken and understand how much value we've added, because we currently sit on top of your existing planning solutions, and make modifications for the plans that they have generated in order to reduce the value at risk. So you can see the typical actions: expedite, de-expedite, increase allocation, decrease allocation, redeploy your inventory around your network in order to satisfy additional demand that's you're anticipating in the future. So we do all of this calculation, but the key question: does your current ERP system or APS solution track the value generated? My guess is you don't really know what that is, but we have a scorecard. We can tell you exactly how much value we have added to your supply chain planning. To emphasize again, how do we operate currently? We currently operate as a system of intelligence, which is the Gartner term, where we add in that system of intelligence on top of your existing planning solutions. And of course, we use the systems of record both as a source of information, but all of the actions would go back into your system of record to take direct action in the ERP systems. So we supercharge your existing supply chain planning ERP systems with a system of intelligence using probabilistic planning. But where's the future? What is the next evolution in supply chain planning? So it is definitely generative planning. Generative AI is a hot topic in the current space. And we know a lot around ChatGPT, which is large language models. We do see some applicability in large language models, but more as a method of inquiry, but not necessarily as a method of prediction. And what Noodle.ai, we're using graph models to actually do the generative planning as opposed to generative text generation. So generative planning, we believe, is the next stage. But where we started from and how we're progressing. So all of the basic solutions out there, they have functional capabilities. Of course, we will still be able to provide you key functional capabilities: demand planning, inventory planning, distribution planning, manufacturing planning, sourcing, etc. But the key point is initially, we only had solutions that focused on these individual functions without an idea of how do we connect that all together. Kinaxis came up with the term concurrent planning, which is about doing demand supply balancing, or in fact service cost and risk trade-offs across your network to be able to do the right trade-offs to achieve your business objectives. But the key point is, you look at that Gartner Magic Quadrant, all of those solutions use deterministic algorithms. So there's no representation of probabilities inside of those planning solutions that have no way of incorporating those probabilities, and therefore no way of predicting the likelihood of being able to achieve your business objectives. That is where we come in with probabilistic planning. So Noodle.ai, as I said, sits on top of these planning solutions. It's been available since 2019. Steve took you through the value that's generated at two of our customers. You can see that there's absolute capabilities or value generation that we bring connecting to the deterministic planning solutions. But then what is next that we have available? So you can see for generative planning, we have the AI that is finished. What we're doing is productizing this like crazy, because of course AI on its own is interesting but not valuable. You have to actually put that into a solution that can actually drive the planning. So that's ingestion of results, of your ingestion of transaction system results, how people have actually executed, and then we bring that into the learning algorithm, which then predicts what your plan should be. So that is ready for execution. We'd be very happy to talk to you about our capabilities there and what we plan to do. So why is this important? So I'm sure all of you have heard of the MIT blackjack teams that went around the casinos in the US. to generate a lot of value to them by counting the cards, and therefore being able to be much more predictive in placing their bets. And again, we go back to the fact that in supply chain, you do not have that information about the uncertainty and likelihood, and therefore it's very difficult, and it becomes an emotional decision. So Jeff Ma, who was in one of the blackjack teams, said why people fail is they ignore the data and analytics for emotion. And ultimately, without that information of the uncertainty and likelihood, it does come down to your gut feel and the emotion, the pressure that you're being put onto to deliver to some value which you cannot predict exactly how you're going to achieve that value. So it becomes a motive decision. So how is this similar to what we are doing with what the MIT students did? We track the cards, they count the cards. Sorry, we track data, they count cards. We predict supply and demand, they predict the risks. We compute the probabilities of being able to achieve certain targets. They evaluate the probability. We help you make the supply chain we help you make supply chain bets. They place better blackjack bets. We conquer waste and boost profits. They were able to gain 60 million amongst all of the teams. So the key message is with generative planning, let Noodle take the emotion out of your planning and provide you that information in which you can make much better estimates of where you actually where we give you much better actions in order to reduce your value at risk and therefore increase the likelihood that you'll be able to achieve your business objectives. So thank you from Steve, Tim, and myself. And we hope that you will embrace the power of probabilities in Noodle.ai to improve your supply chain performance.